So guys, if you have a problem, you want to take the limit of cosine x raised to the cosine x. What do you think you do? How would you do it? Yeah, you'd set this equal to y, and then you would take the log of both sides, all right? So this is a log of the limit of, as x goes to pi over 2 from the left, of cosine x raised to the cosine x is equal to the log of y. All right. Actually, before we took the log of y, we needed to make a deal. That deal was that if you found y, you found the answer to this question. You agree? If I find y, I find the answer to this question. Okay. So then you take the log of both sides, but the whole reason you take the log of both sides is you want this cosine x to come down, right? So what you remember is a log of a limit is really what? The limit of a log. So I'm going to switch this. The limit of a log, okay, oops, this is cosine x, is really the log of a limit. Okay, so what that allows me to do is take this cosine x, because it's an exponent, and move it where? Move it all the way to the front? No, just move it in front of the log, because you still have to take the limit of it. Okay, so this becomes a limit as x goes to pi over 2 from the left. Cosine x, ln of cosine x is equal to ln y. Okay, so what I'm going to do now, sorry, I think I scrolled all the way down. Okay, so what I'm going to do now is I'm going to put in pi over 2. Okay, so what I'm going to do is put pi over 2 here, and put pi over 2 here, and technically pi over 2 from the left. Okay, what's the cosine of pi over 2? Think about your unit circle. Okay, it's 0, right? So this is going to be 0 times ln of, we said the cosine of pi over 2 is 0, right? But remember, there's no ln of 0. So this would only work, because think about ln of 0, right? There's no ln of 0, because you never hit 0 here. So if this were to work, you need to be 0. It needs to be 0 coming from the right. Okay, well, let's see if this is really 0 coming from the right. If I draw this cosine curve, and this starts getting a little bit abstract, but if I draw this cosine curve, do you agree that cosine looks like that, right? And this, let's see, this will be my pi. This is the middle. You make a perfect cycle, so this would be my 2 pi, which means my pi over 2 is right there. So it's true that when I plug in pi over 2, I get 0. You guys good with that? And I just need to know, is it a 0 positive or is it a 0 negative? Let's think about this. I'm coming from pi over 2, from the left of pi over 2, right? So if I'm coming from the left of pi over 2, are my y values positive or negative? You see they're positive? And that's why this is really, technically, this is 0 positive. It's hard to figure that out on your own. If you think about it for a while, you'll see that this y value is always going to be a positive. Like, it'll be up here. It'll be a positive 0, okay? All right, so this tells me that ln of 0 from the right, so here's the ln graph, 0 from the right is actually, what y value am I going to? Negative infinity. So this is 0 times negative infinity. What do I do when I get 0 times negative infinity? I do something else, but what is it? L'Hopital. Okay, anytime you see infinity times 0 or 0 times infinity, you want to do L'Hopitals. So I'm going to do L'Hopitals. Now, to do L'Hopitals, okay, what I have to do is start all over and get a fraction. So I need to force this into a fraction. Okay, you need to use real algebra, not the fake stuff. So if I use real algebra, I force this into a fraction. This is a log of cosine x over, okay, I'm going to put this in the denominator. What does cosine change to when I move it to the denominator? Do you agree? Because if I re-multiply that, wouldn't that come back up here? Okay, so make sure algebraically your expression's correct. Okay, and this is what I have. And if I plug in pi over 2 here, I already decided that, you know, right here when I plugged in the ln side, when I plugged in pi over 2, I got negative infinity. When I plug in pi over 2 here from the left, what's going to happen? Well, cosine of pi over 2, isn't that 0? So what's 1 over 0, guys? And so many of you guys told me on your test it was 0. 1 over 0 is what, guys? It's infinity. Is everybody good with that? Okay, so this is infinity. So what I have is infinity over infinity. Okay, so this is what What type of problem? A L'Hopital's problem. So what I can do is invoke L'Hopital's. And all I can say is, those of you guys who are getting confused, you're not carrying down your limit. I mean, you're trying to save, I guess, lead on your pencil. Okay. Oh, that reminds me, Walker, that pencil you borrowed yesterday, you need to return it. Yeah. Okay. That's okay. That's fine. It's just Ms. Troquet's pencil. It wasn't mine. Okay. The limit as x goes to pi over 2 from the left. And guys, what I'm going to do is I'm going to take the derivative of the top. What's the derivative of log u? U prime over u, right? So this is my u. So the u prime is negative sine x over, and this is my u, So u is cosine x. Everyone good with that? U prime over u. What's the derivative? This is terrible. What's the derivative of 1 over cosine x? Yeah. What's another way to say 1 over cosine x though? Do I know the derivative of secant x? This is really just secant x, right? What's the derivative of secant x? Secant x tangent x times 1, right? Okay, you see that right now? Okay. That's fine. Okay. All right, so I have this awful thing, just wants me to go hurt myself, okay? But if you go look at this, it actually turns out very nice, because let's think about it. What's another way to say secant x? Isn't that just 1 over cosine x? What's another way to say tangent x? Sine x over cosine x. All right. Dividing fractions easy as pi. Okay, let me copy the limit. I'm going to flip the second and multiply. All right. So I have negative sine x over cosine x. Flip the second. So that's going to be times cosine x over 1 over sine x. Right? Dividing fractions easy as pi. Flip the second and multiply. Okay, so what do you get when you flip the second and multiply? Sine x's cancel out. What else cancels out? Cosine x's cancel out. So what I get is the limit as x goes to pi over 2 from the left of negative cosine x. And when I plug in pi over 2 here, what do I get? 0, right? So the answer is negative 0, which is really just 0. Is 0 my answer? No, it's not my answer. 0 is the answer to this left side, okay? But this left side is equal to ln of y, okay? And remember, we made a deal, okay? We made a deal. If you found y, if you could find y, then you found the answer. So if ln of y is equal to 0, what's y going to be equal to? 1. You guys good with that? You just e both sides. You get e to the 0, and that's 1. All right, pass up your warm-ups. Did you like that problem? Okay, you might see it again, so you might want to fall in love with it. All right, let's look at, let's see. Well, you guys have your tests out. You guys done with your tests? That's right, yeah. You guys done with your tests? Put the yellow sheet on top, guys, and don't look at other people's test keys and pass it all the way to the front. There's this plus, this worksheet right here. It's your homework from tonight. We're going to do 1 and 3 together, and you'll do 2 on your own. Okay, and what we're looking at is parametric problems, parametric equations. Okay, I think you'll like this, what we're doing today. It's actually kind of, things kind of come together on it, and it's actually not too hard. All right. Let's look at parametric equations. So today what we're going to start is parametric equation, basically vectors. Okay. And these, how you know something is a parametric equation is you have this extra variable in there, okay? Do you remember this from your pre-cal days? We had x and t's in here. Do you remember that? You had to graph them. Did they take it out of pre-cal? I'm not sure. Does anybody remember doing this? You've seen this before. Okay. So what we're doing is we're saying it's the same thing. You have x's and y's, okay? But now you've just got this extra variable in there. And a good way to think of this is just time. Now you've got time in there. Okay, you have x and y's, you have time in there. Okay, now t doesn't always stand for time, it's just some other variable. But it helps you when you think about it like time. It's like a third dimension. Okay, And what we want to do is we want to graph this onto an XY Cartesian plane, okay? So we're going to graph these two equations on an XY Cartesian plane without graphing the t. The t will be represented in here, okay? But we're not going to have another axis for it. So how do we do that? So what you do is you just set up, you know how we did XY table? Now we're going to do a TXY table, okay? And just like when we did an XY table, you could put whatever number you wanted for X, okay? Instead now, we're going to put whatever we want for T. So I'm just going to say T is -2, -1, 0, 1, and 2. And these are just random numbers, okay? I'm going to plug in. I'm going to try to plot this on an XY Cartesian plane. All right. When T is -2, what is X and Y? So I'm going to put in -2 here and -2 here. So what are my new numbers for X and Y? -3 and -3. You agree with that? Okay. So guys, we're on your worksheets. You can do this. This is your homework. You just do it with me. All right. What about when I plug in -1? So let's plug in -1. -1 there and -1 here. So what are you guys getting? Is it -1 here and -2? Can I get a check on that? Okay. Let's plug in 0 and see what happens. If you plug in 0, I'll get 1 and -1. Let's plug in 1 and see what happens. If I plug in 1 for t, I'll get 3 and 0. And finally, let's plug in 2. Plug in 2, I get 5 and 1. Okay? And what does this mean? Okay, I'm just going to pretend like t is time. This is saying when time is -2, like 2 days ago, I was at position -3, -3. And when time was at -1, 1 day ago, I was sitting at position -1, -2. Does that make sense? That's like a logical way to say it. So if I plot this, now we have a direction, okay, with this picture. So let's go ahead and plot -3, -3 first. Okay, and this is where I am when time is -2. Okay, when another second passes, then now I'm at -1, -2. So let me go find -1, -2. And this is where I am when time is -1. So which direction did I travel? I went that way. Everybody good with that? Okay, so I'm just going to plot my points. And you connect your points, but now you have a direction. Okay, with parametric equations, they turn into vectors. All right, then I plot 1, -1, which is here. Okay, and that's where I'm at the next time interval. And then I plot 3, 0, 3, 0, and that's where I am at the next time interval. And then I plot 5, 1, and where am I at the next time interval? You guys have this on your paper? What kind of curve did I make? A line. It looks like a line anyway. Can I verify that it's a line? Well, let me think. If it were a line, wouldn't it follow the pattern y equals mx plus b? Do you agree with that? Well, let me combine these two equations and see if I can remove the t from these two equations and see if it'll be a y equals mx plus b graph. Let's see, or equation. Well, here, isn't t equal to y plus 1? Okay, well, if t is y plus 1, I can take that t and plug it right into this t. So that means x is equal to 2 times the quantity y plus 1 plus 1. Is everybody good with that? Okay, so this is equal to x is equal to 2y plus 3. And if I solve for y here, okay, I'm going to do some heavy lifting here. Y is equal to x over 3 minus 3. Oh, okay, sorry. I'm not very good at heavy lifting in math. Let me see. X minus 3 is equal to 2y. Here we go. Y is equal to x over 2 minus 3 over 2. Is that better? Okay, thank you. All right, so right here, is this a line? What's the y-intercept? Negative 1.5. Look on your picture. Is that where your y-intercept was? Guys, what's the slope? On your picture, is that the slope? Okay, so this is interesting. What this is this right here, this parametric set of equations, all it is, it's just a picture of a line, okay? And you can graph parametric equations on xy planes, and that's what you need to know. Because later on, what we would do is we'll say, well, what's the derivative of this line? Well, can you find the derivative of this line? Isn't that just the derivative? Isn't that just the slope of this thing at any one point? Right? That's just the slope. And so Later on, when it gets complicated, when it gets complicated, you'll be like, wait, what is dy dx? I've got t's and I've got dy dx's. It's just, if you graph this on an xy plane, it would just be the derivative of that. Okay, so so parametric equations are really just curves. Now, the only additional thing is it's a curve with an arrow. Does that make sense? So now we have direction. Okay, but other than that, not much different. Okay, so let's go to another problem. I want to skip number 2. I'll let you guys do that on your own. Let's go to problem 3. Okay, let's look at this one. We're going to do the same thing. We're going to try to plot this on an xy plane. That means we need txy chart. Okay, so go ahead and make your txy chart. I noticed that the t's, I'm going to take cosines and sines of them. So what I'm going to do is I'm going to change these to pi's. So on this side, I'm going to put quadrangles. So this will be negative pi over 2, 0, pi over 2, and pi. Okay, that's just so I can plug it in more easily. All right, so let's just go ahead and figure out these points. If I plug in negative pi, what's the sign of negative? Let's think where negative pi is. Negative pi is right here. So what's the sign of negative pi? 0, so that'll just be negative 1. What's the cosine of negative pi? Is that negative 1? So that's going to be 1. Okay. Negative pi over 2. Let's put negative pi over 2 here. So negative pi over 2 and negative pi over 2. What's the sign of negative pi over 2? Where is negative pi over 2? Is it down here? Okay, so what's the sign of that? Negative 1, right? So this will be negative 3. And what's the cosine of negative pi over 2? Is that 0? So this will be 2. All right, let's do the same thing. Let's plug in zeros now. This would be a 0. This will be a 0. X here is going to be negative 1 when I plug in 0. Y here is going to be 3. Let me try for pi over 2. Pi over 2, pi over 2. Sine of pi over 2, I believe, is 1. Right, so this is going to be 2 minus 1, which is 1. Cosine of pi over 2 is 0. This will be 2. And then finally, let me plug in pi. So pi here and pi here. So this is going to be 0. So I have negative 1 here. And cosine of pi is negative 1. So I have 1 here. Okay, so let's go plot these. Remember, order matters on here because I got to figure out the direction of my arrows. All right. So negative 1, 1. Negative 1, 1 is right there. That's where I'm at first. Then I'm going to move at time negative pi over 2. I'm going to move to negative 3, 2. So negative 3, 2 is right there. So is everybody good? I'm moving that way. Okay, so I'll put my arrow in just so I'm doing it right. And then at time 0, I'm at negative 1, 3. So negative 1, 3 is 1, 2, is right here. So I'm going to put my arrows in so I don't lose track of where I am. So there. And then 1, 2 next. So plot 1, 2. Okay, connects from the negative 1, 3. And then at the end, I need to plot negative 1, 1, which I've already got plotted here. That's negative 1, 1. So I'm going to reconnect. What picture is it? Is it a rhombus? Okay, let's see. Let's see what picture it is. Let's go back here. And like we did on number 1, let's get rid of our t's. Let's get rid of our t's and try to solve for x, y. Sometimes it's impossible. And sometimes it's possible. Okay, so let's look at this. I want to get rid of my t's. This looks quite impossible, but I do know a relationship between sine and cosine. I know that the cosine, the cost of sin, is always $1. You agree that's an identity? It's always true, right? As long as this t is the same as this t, as long as I put t squared here and t squared here, or 5 here and 5 here, this is always true. This is an identity. Okay. Let me plug into this identity and see what I can get. If I solve for cosine here, do you agree that cosine is equal to y minus 2? Right, so I'm going to put y minus 2 on this side, and that's squared. Is everybody with me so far? Okay, what's sine equal to? Sine over here is going to be equal to x plus 1 over 2, right, if I solve for sine. All right, so this over here is x plus 1 quantity squared over 2 squared. Did I do that right? X plus 1 over 2 quantity squared equals 1. Okay, let me rewrite this. Isn't this the same as y minus 2's quantity squared plus x plus 1 quantity squared over 4 is equal to 1? Does that look like any form that you've seen before? It's an ellipse. Do you see that? So it turns out this picture is really an ellipse, okay, with an attitude, because it's going in a certain direction. Okay, so it's an ellipse going in a certain direction. All right. What is the center of this ellipse? Do you remember? Did you learn this in Algebra 2? Negative, it's the opposite of what you think. So negative 1, comma 2. Is negative 1, comma 2 the center of your ellipse? Go check it out. Check that out. Okay, do you remember if this is 1 here, then down here was your b squared. Do you remember that? And down here was your a squared. Or was it this your a squared? This was your a squared. This was your b squared. Okay, and this was the length of like the half of the major axis or something like that. Your a is equal to 2. So this length here is 2. Is your length here 2? And this length here, b is equal to 1. Is your length here 1? Remember that? That's a and b. Okay, so it works out. And turns out that this parametric pair of equations is actually the equation for ellipse. Okay, so what is the point of all this? The point of all this is this. You are actually not going to be tested on this exactly. Like, you don't have to actually draw anything for me. Okay, but if I tell you, what is dy dx? Okay, what's the derivative of y with respect to x at, let's say, at x equals negative 1? You could come to this picture if you had it, okay? You could say x is equal to negative 1. And guys, what would be the slope right here?
0.
It's 0, okay? That's what it's saying. If you knew what dy dx is, okay, it really is just the derivative of this ellipse at different points, okay? And we can even write an equation for dy dx, and that's what we're going to do next. Are you ready? Go pull out your notes, please. It's just that two-sided page, that one paper that has 2 sides. And you have something that looks real ugly on it. Do you see it? It looks real ugly. You see it on the very top? Yeah, the one that says parametric equations and calculus. Okay, there's one pager. Okay, and I'm going to do number 1 with you, example 1. Okay, and I think it'll be easier if we do it together first, and then you'll understand what that equation means on the top. Okay, you're going to have to eventually memorize that. Okay, but if you understand what we're doing, the memorization will be a lot easier. Okay, here we go. It's the same thing as what I said. I have an x and I have y parametric equations. Okay, they want me to find dy dx. Okay, now I could plot this. Okay, but it's not always easy to plot it. Plus, it takes a lot of time. To find dy dx, you don't really need to plot it. Okay, but you just need to understand that this is a curve. Is everybody good with that? It's a curve on an xy plane. Does everybody understand that? If I wanted dy dx, it's just the equation of the derivative of that curve. Okay, so let's find dy dx. Now I have t's to deal with, so this is the equation you're going to memorize. dy dt over dx dt is actually equal to dy dx. Do you agree with that? Well, what is dy dt? Isn't that just the derivative of y with respect to t? Well, isn't that 6t minus 2 then? And what is dx dt? Well, isn't this really 2 times t to the 1/2? So dx dt, is that 2 to the negative 1/2? Right? And this is a good answer. You could leave it like this, but I'm going to simplify it. So I'm going to move the t to the 1/2 to the top. When I do that, remember, guys, the numerator was a family to begin with. So we don't break up families here in calculus. So you need to just keep that 6t minus 2. Okay, and I'm going to distribute this. The reason I'm going to distribute this is we're going to need the second derivative, okay? And I'm going to get it into a different form to make the second derivative a little bit easier. So let me go ahead and distribute that. That'll give me 6t to the 3/2 minus t to the t 1/2, okay? And so that is my answer, okay? Definitely this was my answer over here too, just FYI. But this one's a lot easier to take the second derivative. So you've got the first derivative. This formula here you're going to memorize right here. And then we're going to kind of try to think about the second derivative. Do you agree that the second derivative is the derivative of the first derivative? Is everybody good with that? Okay, so what does that mean? Well, I've got the first derivative right here, right? So take the derivative of it, right? Let's go ahead and take the derivative of this. Okay, this is going to be 6 times 3/2, which is 18 over 2. That's just 9t. Take away 1 from here, so minus 2 over 2. Isn't that 1/2? Okay, minus 2 times 1/2, which is 1, t to the negative 1/2, okay? But there's something I'm missing. dt dx. Okay, why is there a dt dx? Because I'm doing the derivative with respect to x, right? But this has t's. So I take the derivative like usual, but I have, just like on your test, well, on some of your tests, because some of you guys forgot it, okay? But you have a dt dx. Everybody good with that? Okay. And this is kind of interesting, because do I know what dt dx is? Well, if I flipped it, would I know it? Do I know dx dt? Well, isn't dt dx equal to the reciprocal of dx dt? So another way to write this would be 9t to the 1/2 minus t to the negative 1/2. This is negative 1/2 over dx dt. Right? Because if I took this, dividing fractions easy as pi, flip the second and multiply, I'd get this back. Right? So this is the same as this. Well, do I know what dx dt is? Right here, that's the derivative of x. Actually, I've already done it, right? It's right here. Okay, so this is really the same as t to the negative 1/2 down here. And this is my answer. I'm just going to simplify it. You don't really have to simplify, but it turns out this is not hard to simplify. It's a common denominator. So this is 9t to the 1/2 divided by t to the negative 1/2 minus t to the negative 1/2 divided by t to the negative 1/2. I'm just doing common denominators. Okay, 9 divided by 1 is 9. Okay, what do I do when I have like the same bases, but I have exponents with dividing? Subtract. So it's 1/2 minus negative 1/2, which is just 1. So this is just t to the 1 power, which is just t to the 1 minus 1. And there's my answer. So I want you guys to think about what we did. The first derivative, this was your formula. You guys got that, right? I think you got it. Okay. The second derivative, some things unexpectedly happened. When I took the derivative of dy dx, I had to take the derivative, then I had to divide by dx dt, right? When I took the derivative on top, that was just a derivative with respect to t, right, on top. And then I had to divide by dx dt. So it turns out that the formula for the first derivative looks like this, okay? And the formula for the second derivative, okay, is actually d2y dx squared is equal to, you take the derivative with respect to t of dy dx, and you divide that by dx dt. So this is your formula for the second derivative. And that's what's on top of your paper that looks so bad. Okay? But this is what you'll memorize for the formula quiz, these two boxes. This is only for parametric equations, so it's when you have a t involved. If you don't have a t involved, it's a lot simpler than this. Everybody good with that? Okay. If you don't have a t involved, it's not this bad. All right. So we did number 1. Let's go to number 2. Okay. Number 2 says, I have a parametric equation. And now I want to find the equation of a tangent line. All right, guys, what do I do when I need an equation of a tangent line? A point and a slope. Okay? And students freak out when they see a point and a slope and t's in there. Guys, this is the same point and slope that you had when you had just x's and y's. Okay? A point is just an x, comma, y. And this will help you if you just put x, y there for a point. Okay? Because now with t's, you get all confused. A point is still just an xy point. Remember, we can graph this on an xy Cartesian plane. Remember that? It's just a point, xy. Okay? You've plotted a bunch of points. The slope is the same as you always thought. It's the slope of a tangent line, right? What's the slope of a tangent line? When I say derivative, you say slope of a tangent line. It's just a derivative. Everyone good? All right? So let me find xy here. Do I know what xy is? I certainly do. X is 4 cosine pi, okay? Not pi, sorry. X is 4 cosine t, but what's t? 3 pi over 4. Think about where on the unit circle 3 pi over 4 is, right here. So what's the cosine of 3 pi over 4? Negative 2 over 2. So this is actually negative 2 square root of 2. Okay, so that's your x. What's your y equal to? Well, that's right here, 3 sine of t. Okay, but what's your t in this problem? they tell you it's 3 pi over 4. Okay, so that's going to be 3 times the sine of 3 pi over 4, which is square root of 2 over 2, which is just the same thing, really. Okay, now be careful. This is what my x is, and this is what my y is, but what you want is a point. So, the point would be x comma y. Is everybody good with that? I'm going to leave it x and y like that because they didn't ask me to, expressly put the point. Well, let me just put it. This is the point, just to make sure you understand. If they ask you for the point, that is the point. You need an x comma y. All right, on the slope side, do you remember how I find the slope when I have a t parameter? dy over dt divided by dx over dt. Okay? Be careful, guys. One of the most wrong things students do is they grab this one and take the derivative first. Why is it not, even though this is first, why is it not okay to take the derivative of this first? That's your x, okay? And I do this all the time, and you will sometimes, but hopefully you won't do it on your test. All right? So what we're going to do is we're going to take the derivative of y, put it first. So what's the derivative of 3 sine t? Is it 3 cosine t? All right, what's the derivative of 4 cosine t? Negative 4 sine t. But guys, I need numbers here. How do I change this to numbers? Yeah, what's t really equal to? 3 pi over 4, right? And t right here is 3 pi over 4. Okay, what's the cosine of 3 pi over 4? Is it negative or not? Yes. Okay. Negative 4. What's the sine of 3 pi over 4? Is that just positive? Root 2 over 2. Do we need a unit circle quiz in here? Will it boost your test grade or your quiz grade or not? No? That's sad. And mine's great too because my unit circle quizzes have tangent too, because I can. So, okay, guys, square root of 2 over 2 divided by square root of 2 over 2 is 1. What's negative divided by negative? Positive. So what is your derivative here? 3/4. We're not done yet. What did they ask us for? Equation of a tangent line. So go ahead and write it. It's y minus y is equal to the slope times x minus negative. So x minus x. And there is my final answer. Okay. Tedious, but not hard, right? You guys can do this. One of the things students forget on the test is how to plug in t. I'm not really sure why, but you can, based on the things that they give you, you can find t. Okay, you can always turn all of these into numbers. All right, we're going to skip number 3. We're going to do that tomorrow. And let's go to number 4. Okay, number 4 says, and you guys see the top of number 4, how terrible it looks? I used to do that in class, but students used to go into a coma. And so I'm not going to do it anymore, okay? But you guys can look at it yourself if you want to, okay? But I'm going to tell you the final equation, and I'll explain to you what we're doing. All right, this asks you for arc length. You agree with that? Can you tell me the formula for arc length? Because you've been tested on this, okay? It's it's integral of the square root 1 plus
y to the x squared.
Okay, what is here, though, with respect to what? dx. If this is an x, and this is x1 to x2. Remember, this was the one where if there's an antiderivative, there's also a derivative, okay? Where there's a square, there's also a square root. Everybody good with this in arc length? This formula is great, okay, when there is no t. Everybody good with that? But what if I have a t, okay? Then remember, I know that this is dy over dt, and this is dx over dt, okay? And probably if I were smart, I could figure out another equation for that, okay? And that's what somebody smart did on the top of your paper there, okay? And so what I'm going to tell you is just the result of that. And the result of that is a new formula for arc length, and that is the integral, but now we have t's, so it's going to be t1 to t2, okay, of the square root of dx dt squared plus the quantity dy dt squared. But now we're not doing with dx with respect to x anymore, guys. This is the integral with respect to t. So, guys, if this formula is great when there's no t, what is this formula great for? When there is a t, okay? And what you have to know is they're actually the exact same formula. So if you're able to manipulate somehow, okay, in order to, in this equation, you can get this equation somehow if you're smart enough to manipulate it. Okay, figure it out. And a lot of you guys are, okay? But you don't have to waste time. You can just memorize this formula, okay? Here's the fun part. You ready? This is the formula for arc length. There are two formulas for arc length, okay? On your formula quiz, I would say, give me the formula for arc length when there is no t. Give me the formula for arc length when there is a t. You have to know it, okay? Those of you guys who've done physics, tell me, what is this right here? What is this the formula for? Velocity squared plus velocity squared square root. It's the resultant vector of velocity. Is it not? Well, think about it. Isn't dx dt the velocity going to the right or left? Isn't dy dt the velocity going up and down, right? And if you did the Pythagorean theorem on it, isn't this the magnitude of your velocity?
True.
Okay, so guys, this formula is the same as this formula. Do you remember this formula from October? Do you remember it? You've memorized this formula already. Okay, so now we can know all three formulas. We didn't call this formula S though in October. Do you remember what we called this formula in October? Total distance. So it turns out the length of a curve is really the same as the total distance of a line or a curve. That makes sense, doesn't it? Okay, and they're all the same. Now I need to tell you, this number here must be a function. You cannot, like if you say the magnitude is 5, you can't just put 5 in here, okay? You got to actually integrate it with respect to t. Okay, so just FYI, you just can't put a number in here. It has to be a function with respect to t. All right? Okay, so you're going to memorize all these formulas, and our formula quiz is going to be great, okay? And let's go ahead and do this first problem here, or number 4. Let's do example 4 together. We're actually going to use our new formula for example 4. And remember, you can use any formula you want, okay? It's just that if you know the formula, things are a little bit easier. If you know which formula to use, you can make your life a little bit easier. All right, so this says that if I want the arc length, but now I have t's, so I'm going to use the formula with t's in it, okay? This is going to be the derivative of x. What's the derivative of x? 2t, don't forget to square it, plus the derivative of y squared. What's the derivative of y? Is that 12t squared? Okay, don't forget to square it. This is 12t. Okay, then I need to do what to it? Square root it. Put it inside an antiderivative. Oops, dt. If this is a t, okay, which you need to know that this is a t, what's my smallest t in this problem? 0. What's my largest t in this problem? 1. And how easy is that? That is the answer to this problem. Okay. And of course, if it were a multiple choice problem, they could square this out. Be careful, guys. What's 2t quantity squared? It's not 2t squared. It's 4t squared. Okay, and 12t squared quantity squared, which actually would be 144t to the 4th, right? So if you had a multiple choice, make sure that you pick the right one. Okay, not bad, right? And so on your homework, if you look at number 11 and 12, let's just do it together. We'll finish it up. It's not they want here. The length of the arc of the curve. Okay, well, we know the formula. We have t's. So go ahead and write your formula there. Your formula is the length of the arc of the curve is equal to the integral of the square root. You have t's now, so it's dx dt quantity squared plus dy dt quantity squared. Remember, it's just the magnitude of velocity there. Dt from t is t1 to t2. I'll put the t's in later. Okay. All you do, and this is your homework, is you take the derivative of your x, which is what here? Have I done this problem before? Okay, what's the derivative of your y here? No, this is different. 3t squared, right? You add them together, okay? You get the resultant velocity vector, basically, okay? And this is going to be dt, or resultant, this is the magnitude of your velocity. dt, and this would be from, what's your lowest t value? What's your highest t value? And you can do that, right? Okay, you do number 12 on your own, and we can check it up here. What's the derivative of my x here? 2e2t. What's the derivative of my y here? 3. You could have just put 9 there if you wanted to. Okay, how easy is that? Go ahead and put your limits in, -2 to 2.